Hi, good afternoon. Welcome to the effects and impact of mechanical and control systems in your cultivation facility, sponsored by Surna. Sorry about that. Here with us today is Troy Rippe, the Director of Engineering, Research, and Development of Surna. Brandy Keene, co-founder and Senior Technical Advisor of Surna. And Andrew Lange, Chief Technical Officer, Agrios Global Holdings. So I will turn it over to them.
Thank you so much. Hi, you guys. How are y'all today? So we're going to probably give you a little bit more background about who we are and what we do, so you know that we're actually qualified to speak on this subject first, and then we'll just kind of dive in. My name's Brandy Keene. I co-founded a company called Surna in 2006. Surna's entire focus is on correct mechanical and HVAC control in cultivation facilities. So what my job primarily is translating engineer speak to practical application speak. So basically what I do is explain to people what the various approaches are and what their impacts might be in their cultivation facility to help them kind of make a decision on what type of mechanical systems are right for them. So.
My name's Troy Rippe. I am the Director of Technical Sales and Research and Development at Surna. But my background's, I'm the nerd, I guess, that Brandy's talking about. I'm a little more on the engineering speak side. My background's mechanical engineering, mechanical systems. I spent 12 years prior to Surna in the commercial building world, high energy use buildings, data centers, hospitals, college campuses, evaluating different mechanical systems, bidding different systems. That was my life prior to Surna and where I've spent my career. So I'm going to be speaking more from the technical side, the mechanical engineering side of things.
I'm Andrew Lange. I am the Chief Technology Officer at Agrios Global Holdings. We are a ag tech company with a focus on cannabis. We specialize in aeroponics and other highly efficient indoor cultivation methods. Throughout my career, I've designed a little over 2 million square feet of indoor cultivation facilities, helped manage quite a few of those as well, and have really specialized on facility design, engineering, and building very easy to maintain and run cultivation sites through automation.
So I always joke about how our marketing department puts these pictures of us on these presentations when we're right here. So sorry about that, but.
Well, luckily I only have like 3 shirts I bring to these things, and that's one of the ones for tomorrow. So
Yeah.
That could have been a little more embarrassing.
That picture was taken a whole baby ago, so it's kind of false advertising, but it is what it is. So part of my job is to help people really understand how mechanical and HVAC systems are going to impact their business. And every decision you make when you are designing a cultivation facility is going to have a substantial impact on your bottom line. But it's very arguable that the decisions you make around HVAC and mechanical and environmental control are likely to have the biggest impact out of any of the decisions you make as you go through the design and construction of your cultivation facility. Your mechanical system is typically one of your biggest construction costs. Your mechanical system is going to impact your operating costs through energy, and your mechanical system is going to impact the product that you ultimately produce. So it touches every layer. It's something that really can't be overstated. Troy, when you are working with clients and you're talking about the construction costs, can you give us some ideas of what those impacts might look like?
Well, yeah, obviously every situation is a little different, but certainly the metrics that maybe have applied in other sectors I've worked in or in just other industries, real estate development, your dollars per square foot metric, your dollars per square foot, dollars per light. Some of these metrics, you just almost, dollars per light is a metric that's good to use, but your dollars per square foot, you almost got to throw it out when you're talking about cultivation. So, these mechanical costs, when I meet with folks that are first time or coming from real estate development, and you start talking about how much more the mechanical system is than building, say, this hotel or a normal commercial office building, they're pretty shocked. It can be, every circumstance is different. It can be 30, 40, 50% of, in some cases, of your upfront project cost. And that's just CapEx. When you get into OpEx, what we see and what's been, what we've seen and what's also been reinforced through some studies we've looked at, third-party studies by energy, energy managers, is that the lighting and HVAC end up being, electrical is a big OpEx piece of your facility. And mechanical systems and lighting together, roughly, depending on what flavor of lighting and what flavor of mechanical you go with, they're about 50-50 of that energy. And that total chunk, meaning mechanical and lighting, is 95% of your total electric bill every month. And I don't know if that's what you see, Andrew, but then, and that's not even talking about the plant impacts of actually, having a consistent environment for a consistent crop.
Yeah, I would, add that as cultivators, on average, energy use is in your top 3 monthly recurring expenses, right? And for many cultivators, it is your top recurring monthly expense in controlled environments. Andrew, is that consistent with what you guys see at your facility as far as energy use in the mechanical side?
Oh yeah. So when we're talking about our energy use, almost all of it is within lighting and mechanical. Everything else accounts for the last energy model that we looked at. Everything else accounts for less than 9%. So these big upfront pieces, the more efficient they are, the more this helps us out long term. And as far as energy cost goes, yeah, it's the top 2 with us. Energy, and on top of that is labor. Generally, those are going to be your two biggest things that you're going to be looking at.
What about product quality for you, and how important is, and this is really, when we talk about CapEx and OpEx, that's a component, but really what we're all trying to do is grow high quality cannabis and the most of it we possibly can in the smallest amount of space, right? So when we start talking about the impacts of HVAC systems on our cultivation facilities, arguably the single biggest and most important impact is actually the product that you're producing. So what does that mean to you in your cultivation facility, and what kind of impacts have that environmental system had for you?
Yeah, so with anything, consistency is key. Coke wouldn't sell very much Coke if it tasted different each time. And we have found that the environmentals are really one of the most important pieces of that consistency puzzle. Yeah, nutrients do change things, but you can change so much with environmentals. And if you can keep stable environmentals, you have overall higher grade products that will sell for a higher price. And things are more predictable. These are all the things that you need to be able to run an efficient business. And so yeah, with by having very controlled environmentals, consistency definitely improves. And with that, you also don't have the big problems that kill profitability, such as powdery mildew and things like that. So if you're able to maintain your environments correctly, the entire grow, you're not really having a bunch of risk, which can really stop any profitability that you have the last week of flower when you find out that you have mold because you didn't design your dehumidification correctly. And that can be a huge issue.
We actually have a client who just pushed the panic button on that exact subject recently. Somebody who reached out to us and they didn't work with us on their original design, but they said, hey, we're having some trouble. And they're actually in the process, and guys, this is no joke, they're in the process of $1 million retrofit to correct a design that was where dehumidification wasn't properly accounted for in the beginning. So, so it tells you what a big deal it is to them that they're willing to spend $1 million to go back and fix this. But if they had designed it right in the beginning, they wouldn't have had to spend that $1 million. And that's an actual true story. They were actually in the middle of something like that right this second with one of our clients.
And it brings up a good topic in that humidity control is the trick here when we're talking about mechanical systems. It's fairly easy to add up the heat of your lights, a little bit extra building load, and say this is how much air conditioning I need. But if you just use standard, normal, comfort cooling intended or non-industrial type air conditioning, you're going to get what's called passive dehumidification. Anytime you cool air below the dew point, you're going to get some moisture removal. But you really need to know what you're putting in and what you need to take out. If you want to hold constant relative humidity in your cultivation environment, you're going to need some form of dedicated dehumidification. And that can come in the form of, it can be integral to a unit or it can be outside of a unit, but you're going to need something that's holding on to relative humidity, holding on to that latent load as we call it, and removing that. And those, I think that falls into maybe 3 common methods we see that are utilized for dehumidification. The simplest and cheapest of which is probably just bringing in outside air and exhausting air. The problem with bringing in outside air is that you don't always know, even here in the desert, right, you'd say the air's dry, let's bring that in, see if we can dehumidify the space. Well, you're also letting go of odor if you're doing that, because whatever you bring in, you have to exhaust. You're also gonna have hot, rainy days. It rains here in Vegas. I lived here for a short amount of time. I can tell you it does rain and it's a hot day, and you're gonna bring that humidity in on that rainy day if you don't have some dedicated way to treat that outside air. So that's a method we don't see utilized as much, but if you flip to the greenhouse world, where we're talking indoor growing primarily here, you flip to the greenhouse world, they're using outside air all the time. That's their primary method of both cooling and dehumidifying. The second type of dehumidification we see a lot of times is desiccant type of dehumidification. That's a little more expensive. It pushes to a lot lower dew point. It's what you see in a hockey rink, for instance, or in industrial applications. And that's, if you really want to get cold and you really want to get to a low dew point, desiccant's kind of the way to go, but it does cost a little more. And those desiccants, it's the same process I tell people as the little packets you get in your shoes that have an affinity for relative humidity. A simpleton way of explaining it, a simple analogy, I guess, not a simpleton way, but a simple analogy, is they have an affinity for relative humidity and they want to equalize it. You heat it up, you get rid of some air out, you get rid of some humidity outside and then absorb the humidity from the space. And then the third type, and the one we see applied most commonly, is using some form of mechanical cooling to dehumidify your space. Now that comes in the form of packaged dehumidifiers that we got multiple vendors, I'm sure, on the floor today presenting those. We certainly sell them, we use them. So that's actually cooling the air below the dew point and then either heating it back up or introducing it into the space as both a sensible and latent type of load. So that mechanical cooling basically comes in a couple different forms. A couple on the slide here are chilled water and hot gas reheat. Something we see people get a little lost on, and you're not mechanical engineers, or most of you aren't in this room, I assume, so we wouldn't expect you to know this, but there's different terminology we get stuck on, and one of them is hot gas reheat, and that's using refrigerant as a medium to cool the air, and as a byproduct of that cooling, we have heat we need to reject. That's just air conditioning. You got to reject that heat outside. But you use that refrigerant to actually reheat the air, to introduce it at a neutral temperature. So I'm dehumidifying that air, I'm taking it below its dew point, but then actually introducing it and not taking the room colder than I want it to be. So that's one form of it. The other form we see is in chiller systems. You can actually recover heat at the chiller instead of throwing that heat outside. If you got an air-cooled chiller sitting outside or even a water-cooled chiller sitting in a mechanical room, you can recover that heat, have a hot water loop so you're actually heating water for free essentially instead of throwing that heat outside, and then use that hot water in concert with the chilled water to dehumidify a space without actually subcooling it, which is the passive dehumidification process. If you just were to turn on air conditioning, traditional air conditioning to try to dehumidify, you would actually subcool the space.
Yeah, what Troy's talking about are really probably the two most common effective means of correct HVAC in cultivation facilities. So there are a number of different types of approaches that you can use to, I can throw some mini splits on my grow if I want to. Are they gonna cool it? Yeah. Are they gonna do some dehumidification? Yeah. Is it gonna give me the right result? Probably not. Am I gonna be retrofitting that? Yeah. So what he's describing are the two that we see most commonly utilized that are really effective at what they need to do. And they have some pretty distinct differences. The primary advantage of both of those types of systems that he's describing is that we can dehumidify for low energy use. because we can reuse the heat, the same heat that we're pulling out of the facility, and inject it right back into the facility to make the dehumidification process temperature neutral. And essentially what you're doing in cultivation facilities is dehumidification as a primary function, and you get enough sensible cooling as a byproduct of dehumidification to maintain temperature correctly. If we really focus on correct dehumidification as a primary function. Obviously, sensible cooling is also incredibly important, but the hard part is really the dehumidification part. So what are some of the distinct, we've talked about how those two types of systems are similar. How are they different? What are the differentiating components of the two types of systems?
I would say the big differentiator is with a chilled water system, we have introduced a chilled water loop between where we're removing heat and the building load where we're actually treating the space itself. So primarily hot gas reheat is a dehumidification strategy when you have a refrigerant to air heat exchanger, which we call package units, rooftop split systems, meaning we don't have a chilled water loop, which I always equate to like the radiator in your car. It's a closed loop of water that we're not adding water, we're not subtracting water, this isn't evaporative cooling, this isn't a pad wall. We're just using a closed loop of water in a circular pattern in a chilled water system. Well, in a chilled water system, that by decoupling the cooling load from the actual room load, we can play with variables like water temperature coming out of the chiller. We can play with hot water temperature coming out of the chiller for the reheat capacity. We can play with flow rates. So we can really dial into what the grow exactly needs. But you do have the added complexity of a chilled water loop throughout the building. With a hot gas reheat system, you're actually just taking the air from the space through ducting, primarily normally through ducting, outside of the room, treating it, cooling it, dehumidifying it, and then using that heat from that refrigerant to the air, then ducting it back into the space. So you've removed that whole chilled water loop from the equation. I would say the downside, those systems usually are less expensive. They can be a little simpler, but you do have some odor concerns in bringing the air outside of the space through ducting. No ductwork's perfectly sealed up. And then, the other concern is those capacities are fixed. You buy a 10-ton package unit, that's a 10-ton package unit. And you can't make it 11 tons and you can't make it 8 tons by changing the temperature or changing. So, those are some of the trade-offs we're talking about. And it's going to be hard to get into all of them here and talk about it in a half hour. But those are the things we talk about at Surna, and those are the things that a lot of times the conversations we're having with clients.
Yeah, I always like them because of the flexibility and the redundancy component. Decoupling that compressor from the room itself it allows you some flexibility on redundancy at low cost. And then when you're operating flowering rooms on a flip, I see that as a pretty substantial benefit of that type of system, being able to reduce my connected infrastructure load, right? I can have fewer compressors to operate my facility, I can spend a little bit less money, and if I'm power constrained, I can really help myself there in that type of situation. Andrew, you have a chilled water system on your facility in Washington. Why did you choose that particular system, and what's been your experience with that type of approach?
So we chose chilled water for a few different things. One of the primary ones is energy efficiency. Then on top of that is redundancy, right? Your mechanical system is the most important thing that you have in your building. If it goes down, you can't grow. So chilled water loop allowed us to have enough redundancy without having a really large price. When you're talking about ducted units and things like that, to get redundancy, maybe you have to buy 2 of them, right? Well, one of them is just going to sit there for a while and do absolutely nothing unless you actually need it. Whereas with the chilled water loop, we have multiple air handlers inside of one room that is all fed by a couple chillers that can feed the whole system. And so right there, we're very redundant without having just capital sitting there. On top of that, our approach is a extremely clean approach. So we like the idea of having sealed rooms. Ducts have a lot of problems. When you're moving air through them, you're pulling out, you could be pulling out mold spores or anything like that and depositing them into ducts, and then you just can't clean things like that efficiently, not very often. And so by using the chilled water loop system, we don't have any ducting, we're not pulling any air from outside, we're having a completely sealed environment that allows us to maintain a very sterile environment.
That's great. In your facility, you're using a series of ductless fan coils distributed throughout the space, so that allows you access to that coil to sterilize it between harvest, do all those things. Do you find that it gives you a little bit more consistency, not having to deal with air balancing, and a little bit more control over zoning, doing it that way too?
Yeah, and having zones is definitely important. We zone our rooms a lot differently than most people. When we actually do a zone, it's for what would be one row of our plants, and there's a slide coming up with some pictures. But when we have that amount of control, we can actually change the temperatures on these different zones for different strains or different requirements that we need, things like that. And it's just a lot easier to be able to get up and maintain the systems as well. It's a really quick thing to sterilize an air handler instead of a duct.
Yeah, and some clients prefer to have an air handler outside the space pushing air through ductwork, and I think in a lot of cases, obviously what we do is based on what the client wants, and part of our job is to kind of talk through what all those options are and what the pros and cons of the various options are. But I personally, if it were my grow, and I really like that ductless approach, actually that I think is a photo of another duct. That's not Andrew's facility, that's a different facility, but it's got some ductless fan coils in there also. So let's talk about controls.
Let's.
And it's interesting in our industry, controls contractors in the cultivation space are a little bit different than controls contractors in the building automation space. And what we find, you have there's a difference between giving you a user interface that tells you what's going on in your facility and giving you actually control over what's happening in your facility. So generally speaking, when we're talking about controls, we've got all these layers, right? We've got monitoring of what's actually happening in the facility. Then we've got to control the equipment that responds to whatever that monitoring is, right? And then you've got the automation component where your control system actually knows what it's doing and is automatically adjusting to whatever those components are. And what we find a lot in the industry is that we have a lot of controls companies that are really largely monitoring, right, and giving you a user interface, but may not be actually controlling the equipment itself. And certainly are not necessarily automating that process. Troy, Troy's been working very hard at Surna, he and his team, on advancing that within the industry. So.
Well, my team, I want to give them credit more than myself, but it's certainly been a challenge. And I think just taking a step back to what Brandy was saying, the word controls gets thrown around a lot, and I think it's useful to define, controls can be monitoring things, controls can be sensing things and through monitoring. A simple, example of a controller is a thermostat. It gets hot in your room right now, in your hotel room. It gets hot, it turns on cooling. That's a simple control loop. And then there's what I would call advanced automation or automating a facility, which is actually making a smart facility, proportional control, modulating things, actually locking in. The example is if you got a staged piece of equipment, if you're only turning something on or off, if you want to go 50 miles, if you only got 100 miles an hour or 0 miles an hour as your option, you're going to go 100 for half the time and 0 for half the time and go 50 miles. And that's okay, that works, but if you really want to control things precisely, you want to be able to modulate from 0 to 100, and you want to be able to pick 50 miles an hour and just go there, because that's the most efficient way to get there for your car building systems, mechanical systems and HVAC systems aren't that different. If you have the ability to design something that can modulate, if you have to design something that's smart, that's intelligent, that can pay attention, and actually find the optimal point to operate for your facility conditions, but also do it energy efficiency-wise. And not only do that, but benchmark it, track it, so you know exactly what you did. When you bump that strain up 5 degrees, in the first 3 weeks of flower, it actually saved you energy and it increased yield. You want to make those cause and effect connections. And that's what automation should be doing for you. And so, we're sticking to our lane. We're in climate control. We're not trying to automate your whole facility. I'm not going to be out here trying to sell you an ERP platform, because that isn't what we do. And I'm not, we're not necessarily trying to control fertigation, because that's not what we do. But when it comes to climate, we have engineers in-house. We're writing sequences. We're trying to make the most efficient, highest performing systems possible. And this controls launch just was a necessary step for us to actually do the climate control piece in the garden so that we could make sure these things were getting done correctly. And we reached out to the industry partners that are in the automation space, and it's what they wanted us to do. It's not like we're trying to step on their toes. It's what they said, hey, you guys are good at that, you should be doing that. And so we are proud to announce that we, shameless plug here, I guess, but we are offering this as in our offerings now as something we think is a really nice add-on and a really nice advantage for cultivators building facilities.
Yeah, so when we talk about this type of control system, we're not just talking about a piece of equipment that allows you to turn something on or off. We're talking about an actual program that understands what's happening and is responding in the most energy efficient way possible to what's happening. And as Troy was talking about, if you're either on or off and you need to be somewhere in between, well, then you're using a lot more energy than you have to get to where you're going, right? And then secondarily, that on-off type of approach typically leads to some variances in the consistency of the cultivation facility. So if I'm turning it on and turning it off and turning it on and turning it off like I would in my home, then I may have wider tolerances for temperature, humidity, all of those components that are so important to me in my cultivation facility than I really want. So the better I can modulate those responses, then the more precise that environment's going to be, in addition to using only the amount of energy that it has to.
And it's called a PID loop. It's nothing new in controls vernacular, but it's just, if 13% open is the right place to keep you at a steady state, and talking about a trend line, which I think there's a picture of one later, keeping a nice there's a slide for that. That's good. But if you're turning things on or off, you might trend over certain temperatures and humidities, and it would look a little more jagged going up and down and crossing over the line with an overall trend. But when you got a full modulating system, when you can actually lock in on, say, 13% open is the right place for your valve to be, you can get lines that look like that. That is fully capable of happening in a cultivation facility. The system learns when the humidity spikes are, learns when your watering event is, learns the optimal temperature and humidity. You can get trend lines that look like that, which, going back to the beginning of this discussion and probably transitioning to Andrew here, are gonna have consistent crop quality and optimize energy savings, and help you to find those cause and effect relationships. And we're well aware temperature and humidity are only two of them. There's fertigation, lighting, it goes on and on. It's everything you're here to learn about. But, maybe, Andrew, I know you don't have our system because it just got launched today officially right now. But maybe you could talk about some of the challenges you've seen what you've seen of the power of automation and control.
That's my favorite picture of Andrew, by the way. I love that picture.
So when we get into controls, we start to realize how important they are, and they're right. Modulation control is more important than on-off. When you go on-off, you do get swings. That's just the way it's going to work. Your air conditioner is going to come on. I would say you set it at 78, and it hits 79. It's going to come on, and it's going to have a duty cycle. So it may overshoot the temperature just because it can't turn off quick enough. Things like that. Those don't lead to those really nice trend lines like was on the last slide. But they're extremely important for your consistency of product. We want to minimize any of these large shifts and stuff in cultivation. Then if we can do that with our climate, then we just have more control and are able to look at all these other things: fertigation, irrigation schedules, how often we're watering. Then we can really do a causal relationship with a lot of these environmentals. If we know that we've been actually running something, and we not only have data tracking, but we have analytics, right? Because just getting a data point doesn't really tell you anything. You have to get a lot of data points on a lot of different things to really learn anything. And that goes all the way through to testing. You may think that you guys have done a really good job it turns out if we lower the RH 10 more percent, we increased our yield by 5%. But did it increase testing? Did it decrease testing? What does it do? And all those data points come together to allow us to build better grow plans. And to build a really good grow plan, you have to have control. So,
and to feed a good analytics platform, you want to have trends, you want to have history, you want to have historical data, which we're attempting to capture for the climate. But if you had a really good run and you just blew it out and you just harvested, you want to know what temperature and humidity you were running when and where, in combination with your lights, in combination with your nutrient regimen, in combination with all these things. So if you're flying blind by using a thermostat and just setting temperatures and trying to remember, maybe logging it in a book, it's not as powerful, it's not as good of a tool for you as it should be as a cultivator.
Yeah, I agree. Every change you make that is going to impact the metabolism of your crop, right, is going to have an impact on your end result. And that could be as substantial as yield and passing tests for mold, or as minimal as consistency and having a client who bought one of your products for knee pain and then went back to buy the same product 6 months later. And if your bulbs were a different age, or if your nutrient changed a little bit, or if your temperature or humidity changed a little bit, then likely the physiology of your crop changed also, right? And then they might have a different experience. So there are a number of considerations around the data that you're collecting as you perfect your recipe for whatever strain it is that you're cultivating. So it's as this market gets increasingly competitive, obviously we're looking at cost of manufacturing as probably our primary marker, right? How much does it cost me to produce a gram of cannabis? That's going to be your leading indicator of success. But then within that is that Coke model, right? If I bought a Coke in 3 different stores and it tasted different 3 different times, I've been to restaurants that were awesome the first time I went and then they were terrible the second time and I never went again. They're not getting another chance, right? Why would they? And as a supplier of medicine or adult use cannabis, you're going to be held to the same standard, and so it's pretty important.
It's about building brands and
Yeah.
brand consistency and brand loyalty.
Yeah. That's all we got, guys. Any questions?
We kind of tried to cover a lot in a short period of time. So
Yeah, and Troy
apologies.
nerded out, so sorry
I did
about
nerd
that,
out
guys.
there. I blacked out for a second.
Yes, sir. Hi, Bruce.
Hi, Bruce.
You might just need to get closer to it. I just got lessoned on that myself. Is Bruce's mic
We can
loud?
repeat it
We
for
can
you,
just
Bruce.
repeat it if you just want to say it loud.
Yeah.
I'm Bruce Strawn from Denver, Colorado, the Mile High City. I'm an HVAC engineer. Thanks. I do expert witness consulting. One of the biggest issues I've run into in my world is odor. So I was wondering, could you give me just a quick overview of the major considerations that would go into an odor control plan that you would recommend to a client for a large facility that has a mother room, a nursery, a veg room, the flower room? Would you only be concerned about the flower room? Is a carbon filter the most effective thing? And I've seen some places where they want to keep positive pressure in the flower room to keep microorganisms out of there and everything, but not considering the odor leaking into the corridor and other areas. I mean, is that also a concern?
We see all these challenges, right? Positive pressure, negative pressure, there's pros and cons to each. Neutral pressure, which is something we like. And we don't push clientele one way or the other unless if they have a strong opinion. Generally, we like a sealed room. So we don't like to bring in a lot of outside air or exhaust air unless we have to, unless there's a CO2 event. We design systems for flushing if there is a CO2 event, or in the case when they might want to flush a room, they had a bug, they had a pest, they had a whatever, for whatever reason, we'll design those systems. But we like to think of them more as an emergency system, and it depends, a lot of this gets into code compliance and dealing with your local code official and how they interpret the code. And we're working nationwide and in Canada, so we see a lot of different flavors of that. But there's no magic wand necessarily, other than we like to treat the air in the building if at all possible, and even better in the room, versus taking it outside. As you're a mechanical designer, you probably know no ductwork's perfectly sealed up, no units are perfectly sealed up. So just inherent to that, we're going to be taking odor outside to treat it, to cool it and dehumidify it or heat it, as the case may be, and that's got inherent issues. So if we have our druthers, we would keep it in the space and treat it in the space, but we're also aware that that's not always plausible. Some people don't want to, there's pros and cons to all these decisions. So it's,
Well, the advice that we would give, frankly, would depend on whether they've already got a mechanical system and are trying to correct it, or if they're designing something from scratch. Because if they're designing something from scratch, then the trick is basically to very carefully control the flow of air, right? Any air that's leaving that building is going only where you want it to go, and that's through a filtration system of some kind. Usually that's some kind of a carbon filter and ozone, or one or the other. Or you're using both at your facility, right, Andrew?
Yeah.
Yeah. And so your main goal is just to very carefully dictate where any exhaust air is going. And if you do that, then you can typically minimize the amount of recirculating odor control you have to do in the building. And flowering rooms are your worst culprits. Mother and veg rooms don't typically have that real typical cannabis smell. They usually just kind of smell musty and like dirt. It's really flowering rooms, and then your post-processing rooms, your dry rooms, your trim rooms. Trim is I mean, that's the stinkiest room in the building, once or twice a week, or however often you're trimming. So if someone's already got an existing facility and is having some odor control problems with that, then we would take a good look at their mechanical plans and find out where the air is leaving and figure out how to mitigate that. So do you have anything to add there, Andrew?
we were talking about this earlier, I think.
Yeah, we were.
I think you hit on pretty much everything.
Yeah, it doesn't stink in your building.
No. Ozone is a great thing, if used properly, ozone and with carbon filtration. But also to hit on one thing, especially make sure your dry rooms have their own standalone systems, because they are going to produce a lot of odor. And that you generally don't want those tied into anything else in your building anyway. And then with trim rooms, not only is odor mitigation extremely important, but actual air filtration is extremely important. Use at least a MERV 13 filter inside those rooms, because there's a lot of airborne particulate when you're using mechanical trimmers. And both of those things will help with your odor mitigation as well.
That's a good point.
Yeah, and you were, if I remember right from earlier, you're not advocating ozone in the space. It's ozone on the exhaust prior to leaving.
Yeah. So if you're
to be
using
very
an
clear,
exhaust
if anyone
system,
knows.
Also don't mess
don't
with
put ozone in your
Don't,
plants.
don't stick your face on an ozone generator.
If you're going to use ozone, make sure you contact a mechanical engineer to design the system correctly for you. Don't just go out and buy an ozone generator and start messing with it.
Right.
Anybody, any other questions? Really? There's a lot of you. All right, well, we will very happily see you at our booth when you come to ask the questions in private that I'm sure that you all have and don't want to advertise. So thank you all for coming.
Thank you.